All right, last day of the lesson, trapezoids. So we're going to be able to apply the properties of a trapezoid, all right? All right, so first off, we have the basic trapezoid, right? So a trapezoid has one pair of parallel sides, right? So we have exactly one pair of parallel sides. Obviously, this is not a parallelogram because it's only one set. So that is the definition of a trapezoid, right? So BC would be parallel to AD, okay? However, we have what's called an isosceles trapezoid, and now we have a whole lot more stuff that's going on, right? So let's talk about the isosceles trapezoid. So again, if you're looking at our family tree that you should have in front of you right now, there's just a basic trapezoid picture. So this is just a trapezoid. And the only thing we can say for sure is that we have bases that are parallel, right? So like AB would be parallel to CD. But then we have an isosceles trapezoid right below it. And just like an isosceles triangle, an isosceles trapezoid has two congruent legs. Right, so again, if this is we'll call it trap. How about that? Trap for trapezoid. So we still know that our bases are parallel. So one property is that AP is parallel to RT. Right? But we also know, right, that the legs are congruent. So AR is congruent to PT. Right, those are the legs. Okay. We know that the base angles are congruent, okay? So the base angles means that we have two bottom angles. That's one of the bases. And then we have AP is going to, or angle A is going to be congruent to angle P. Those are the top base angles, right? So the bases are the sides that are parallel, and then the base angles are the sides that correspond with that, or the angles that correspond with them. So base angles congruent. And again, in this example, it would be angle A is congruent to angle P, and angle R is congruent to angle T. Right? So the bottom angles are congruent to each other, the top angles are congruent to each other. All right? We have another relationship as well, and that is we have some supplementary angles. So a bottom and a top base angle are going to be sup. So upper base angle sup to lower base angle, right? So angle R plus angle angle A plus angle R would be sup A sup to angle R. But we also know that angle A would be sup to angle T because that's also a lower angle. We know that P is going to be sup to angle T and angle R. Any lower plus any upper sup. Okay. We also know that diagonals are congruent. Okay. So this is property number 5. Diagonals congruent, right? So AT is congruent to PR. Right? And then this is kind of a weird thing that happens, but, and I should probably label this, let's call it M for where they get bisected. We end up creating two isosceles triangles, right? So this triangle that's created by the diagonals is an isosceles triangle, which means our M is going to be congruent to MT, right? And this angle is going to be congruent, so MRT would be congruent to TRM. So it's kind of like a weird, I'm just going to write that triangle RMT is isosceles triangle, right? And this little guy up top is also an isosceles triangle. And triangle AMP is isosceles triangle. And this is because of all the properties that we have, right? We can end up proving alternate interior angles are congruent and use some transitive and substitution properties. And I promise you I will not bore you with that, but it's a little bit of a side fact. So we do have two isosceles triangles created, and then these two triangles are actually going to be congruent, right? And again, these are just kind of little weird side things that happen in a trapezoid. All right? Okay. We're not going to do that one because it's a proof by contradiction, which is icky. So we're going to say, example 2, ABCD is an isosceles trapezoid and it wants us to find some measures, okay? So again, we're going to use the properties of a trapezoid in order to do so. All right, well, I have parallel lines, that's for sure. So we could figure out all the different angles based on what we know already, all right? So we just went over one of these weird properties, but this guy right here is an isosceles triangle, which means the two angles are congruent. So if this is 28, so is that guy, right? Very awesome. We can also figure out what this angle is, right? Angle E, because this is a triangle, so what's 180 minus 28 minus 28? Well, that's equal to 124 degrees, right? So that's 124 degrees. Well, guess what, guys? Vertical angles are congruent, so this is 124 degrees, right? We also have alternate interior angles, which means this is 28 degrees. Isosceles triangle going on the bottom as well, so this is 28 degrees, okay? So we are just knocking some of these angles out of the park. All right, well, we have a linear pair here, so this guy is going to be equal to 180 minus 124. So we have 56 degrees, which means vertical angles. This is also 56 degrees. And we can figure out our missing angle up here by a couple of different things. We know the upper and the lower angles are sup. We also know that these three angles are going to be a triangle. So either way, let's do 180 minus 56 minus 47, which means we have 77 degrees. And the same thing is going to happen over here. There's late buses, crazy, right? And we've found all of our angle relationships. All right, not too bad. All right, so this guy says in trapezoid ABC below, AD is parallel to BC, and diagonals AC and BD trisect at E. The measure of ABC, this angle right here, is 130 degrees. And the measures of the distances in centimeters and angles are as marked. Wants me to find the length of AC in centimeters. All right, guys, this one, super easy here, okay? We have a trapezoid, right? Okay, we also know some lengths here or we also know what's going on, what kind of trapezoid this is, because we have base angles that are congruent, right? This guy's 130 degrees, and so is this guy. So this is an isosceles trapezoid. Base angles congruent, right? Which means diagonals are congruent. So what's our first diagonal? It's BD. What is 2 root 3 plus 6 root 3? That is 8 root 3, which means our other diagonal is going to be 8 root 3, because diagonals are congruent in isosceles trapezoid. Wow, not too bad. Okay. One more to wrap it up. So we're going to justify what kind of trapezoid or what kind of quadrilateral we have. Let's graph it first. Negative 9, 1. That's A. 2, 3. That is B. Of course, it's not going to stay on the graph. We have 12. Negative 2 is C. And negative 10, negative 6 is D. All right, so it does not appear to be a parallelogram, but we're going to find slopes as always. So let's count. I'm going to go up 1, 2, 3, 4, 5, 6, 7, and over 1. I'm going to go up 1, 2, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2 over 11. I'm going to go up 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Was it 6 over 10? That was to the left, so negative 3 over 5. And then we're going to go up 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 4 over 22, which reduces to 2 over 11. So we definitely have one set of opposite sides parallel, right? So we know it's a trapezoid. Now, the only way to determine if it's isosceles or not is to use the distance formula, unfortunately. So we have to find the distance of AD and the distance of BC. All right, again, this is in our room, and I will give it to you on the test, but it's x sub 2 minus x sub 1 all squared plus y sub 2 minus y sub 1 all squared. And I'm going to plug in the distance formula to AD. When I did that, I got the square root of 50. And when I did it to BC, I got the square root of 125. And last I checked, not congruent. So this is just a trapezoid, not an isosceles trapezoid. So we do have to do the distance formula one time for trapezoids. All right, that was a lot, I know. Here's the homework, page 238, number 8, 245, 7, 17, and 20, and 259, 6, 11, 13, and 28. We do have a quiz tomorrow covering our shapes. And then we will be reviewing our angle relationships on Friday. Get ready to dance. Talk to you later.